Hello, and welcome back to the Lancaster Farming Industrial Hemp Podcast. I am your host, Eric Herlock. And so, hey, last week I was up at the Pennsylvania Farm Show. I was talking to hemp historian Les Stark at the Pennsylvania Hemp Industry Council booth, and he had this
Hempcrete block. Now, I've known about hempcrete for 20 years, but the hempcrete block that I have in front of me is a little bit different. This is the first time I've seen it like this, and this is has his you stack it like Legos.
It looks like a giant Lego.
Right, and with the holes in the center for the rods to go through, and that gives it a lot more structural strength and integrity.
So I called up Just BioFibers in Alberta, Canada, and had a conversation with Michael deChamplain, and today we're going to hear that conversation about giant hempcrete Lego blocks. Stay tuned. Hey listeners, if you're not a current subscriber to Lancaster Farming Newspaper, now's your chance. We have a special deal for you. Just go to lancasterfarming.com/podcast deal for a discounted offer on the #1 agricultural newspaper in the Mid-Atlantic region. So check it out, lancasterfarming.com/podcast deal. Okay, back to the show. Michael deChamplain, welcome to the Lancaster Farming Industrial Hemp Podcast. Can you first start by introducing yourself?
Yes, I'm Michael deChamplain. I'm a founding director and first investor in a company called Just BioFiber Structural Solutions Corp. I started with the company 4 years ago, and since then we've developed a new building system that uses hemp and lime with a structural frame that goes together like Lego, and we have been pushing that along. We believe it's a game changer in the construction world.
Okay, and how are these blocks being received by the general construction industry?
You know, I don't think we haven't done any marketing, and yet we have about 25 million worth of sales, if we want to call them that. Everybody that we educate wants to use the building system because of the incredible performance of the building envelope. So we have never had any problem meeting our sales. Sales is not an issue because of the performance.
Okay, can you explain the performance?
It's odd. People don't see how this can happen, but we have a 2-hour fire rating to start with. That's pretty important especially in California these days. Mm-hmm. The 2-hour fire rating is in existence. The next thing is that the walls actually breathe, so it's not like a completely enclosed building envelope where you have problems with moisture and mold and things like that. That doesn't exist. All of the material that's used is non-toxic and the walls breathe, so we actually have a declare label saying that there's no toxic materials in our formulas. You give all their formulas and they check them out and give you this label. Okay. But I mean, at the end of the day, it's about our value and energy performance, because our original goal was to have a wall that had no thermal breaks in it, so that the barrier was there and the thermal value was high. We've confirmed R40. And I don't know if you use that rating down there, but it's a significant energy efficient wall. I'll put it another way. In the cold winter up here, in one of the buildings that we built, where we had all of our instrumentation for measuring in situ, the man who owns the house that we built charges 2 Teslas. All of the heat and light in a winter month cost him $20.
Wow. That's amazing. Now, is that something special that you're doing to the product, or is a lot of that just from the natural characteristics of the ingredients?
It's the natural characteristics of the heat of the line. The other important and the BioFiber. There's other. When you squeeze the hurd, which is the waste product from the hemp plant, we're not dealing with fiber, by the way.
Okay.
We sometimes make the mistake of calling it fiber, but it is the actual core of the plant, which used to be used just for animal bedding or thrown away or plowed under. You can't really, there was no other use for it before other than animal bedding that we know of. So that's what we use. And when you squeeze it, when you squeeze the hurd core, it's spongy, so there's air pockets in it. So that helps with the thermal the thermal characteristics of it. And plus the lime. Now the lime really comes into play when the walls are exposed to heat, because the heat does not go through lime. The protons don't go through lime. They get refracted. And this we found out through looking at how they build high-rises in Dubai. They put a limestone barrier on the south-facing wall to keep the heat out. And the reason is that the sun doesn't go through lime. That's the other thing about this in situ testing that we're doing. Mm-hmm. On a hot day, in this past house, which is what we call stick frame up here, which is conventional building.
Okay.
His temperature variation in his house, in his old home, was between 17 and 30 degrees. So he would need air conditioning on a hot day.
Wow.
The temperature variation on the same day in this house, in his new house, is between 19 and a half and 23 degrees. So that's Celsius, by the way.
Right.
So he does not need air conditioning. And the reason is the only variation is because of the windows and doors in the home. And the sun does not penetrate otherwise. So you can, manipulate the windows and doors so that you have very, very little penetration of heat, and therefore no need for air conditioning. That's a big deal up here even. So I imagine how much of a bigger deal it is down in the U.S.
Right. We do get hot down here. Does your company also design the buildings, or just create the materials? We have people that build the buildings. We have builders up here, and we have consultants that work for the company that would go anywhere and build the building. So if you had a design that you were fond of, then we would run it through our system and redesign it. So nothing would change on the actual design of the building, but it might be variation. There might be variations in the length of the wall, for example, or there would be variations to have the best block count or the best use of the materials. Okay.
The intention of the design would be the same, but once it's run through our system, we have what we call a block count. And the block count is not just the blocks, but all the additional materials that you need to go with the blocks to set it up. And it sets up like Lego. We now have a underground block, which is not hemp and lime, and which we tried. The initial one that we've used has been soy foam.
Okay.
And that soy foam block went up in a 4,000 square foot building went up in 3 days for the foundation.
Wow.
The rest of the building went up in 21 days, which is pretty impressive. And so that was when the builder, it went up so fast that the builder had to reschedule his trades because he thought it was going to take longer.
Right. Speaking of the trades, how do the plumbers and the electricians and everybody, how do they deal with this new material? What's the learning curve like for them?
Yeah, electrical, it took the electrician about 15 minutes to figure out, what he had to do, and his job actually was easier than what he's used to.
Okay.
In the block itself, in the manufacturing process, there are holes in the block, if you like, which are all perfectly measured from one block to the next, so you know exactly where these holes are.
Okay.
And the structural frame that holds the blocks together, you know exactly where the struts are, which are the posts that come up through the block. So you know exactly where they are throughout the whole building. So anything that you want to strap onto the building, either we strapped on rock and brick for outside facades. You can strap on any kind of finish that you want. If you don't want to just put stucco or something like that on.
Okay.
But in the interior, in the electrical, these conduits, if you like, are already in the block for the perimeter walls. Okay. And most of the electrical comes in the perimeter walls. So these, you just drill in on a 45-degree angle, and you keep stacking the blocks up. And a tube goes in, the same tube as they use for concrete conduits.
Okay.
For the wire, to keep the wire from being exposed to the concrete. We keep it from being exposed to the lime in the blocks. So that goes up as you build, and any parallel, there's a blade that goes on your saw, and you just use a dado blade and run the wires horizontally.
Okay.
Those holes in the block were originally put in to pull CO2 into the center of the block in the manufacturing process. And so all we did was widen them for the electrical.
Okay.
And most plumbing stacks are in the interior walls. So we're not concerned with them. We're only concerned with exterior walls at this time. And whatever plumbing stack, if you wanted a plumbing stack on a perimeter wall, all you do is router it out. It's just very easy to work with this material.
So what are they building the interior walls out of? Just standard frame?
Just a stick frame typically right now, although we do have a design coming for interior walls as well.
Okay.
But that design is not finished yet. We're working on that. We're also working on a roof system. We have the underground and the perimeter walls at this point. The roof and the interior walls are in the design stage at this point.
Got it. So what, the underlying idea here is that you want to capture as much carbon as you can to take it out of the atmosphere?
Yeah, each block captures 6.5 kilograms, so per block of carbon. So it starts in the farmer's field. This hemp on the Agriculture Canada website, it says that growing hemp sequesters 5 times what a mature forest would sequester in carbon.
That's amazing.
It's a very aggressive plant, so it takes in a lot of CO2 as it grows. Also, the plant is really good for, rejuvenating the land, because it's a taproot that goes down into into the ground, and that root stays in there and adds nutrition for the soil. So the growth cycle of the hemp is very aggressive, and that's where a lot of CO2 is captured. And then in our manufacturing process, we have enclaves where the block is actually cured with CO2. So we pump CO2 into an enclave where the block cures for 3.5 days before it goes to the construction site.
Okay.
So it absorbs more CO2 in that phase, and then after the building is built, it continues to absorb CO2 because it hardens over 100 years.
Oh.
And it hardens with CO2.
Now, how do you know that it hardens over 100 years? How do you test for that without a time machine?
We had a fellow at Purdue University tell us that.
Oh, okay.
Who's an expert.
Right. And then you source, let me back up a minute. So Canada is way ahead of us in hemp production. It's been legal to grow as a commodity crop up there for, 20 years or so?
Yeah, since 1998.
Okay. And then so you source it from local farmers. Are you in British Columbia or Alberta? Where are you?
We're in Alberta. We source it from Alberta agriculture right now, and they have a facility up in a decortication facility up in Vegreville, Alberta.
Okay.
So that's where we're sourcing it right now. There are other facilities being built for this because the market for hemp fiber is taking off. The car companies are starting to use it. They've been using it in Europe for 10 years, so the fiber is very strong, and it's a much better way of reducing injury if there's a crash. Plus, it's lighter and it doesn't off-gas the way the things that we're using right now do.
Right.
So that market is very strong in Europe, and it's starting here. We've got 2 car companies now in Alberta that are picking up hemp fiber for their panels inside the cars.
Right. Yeah, here in Pennsylvania, it's just in the infancy of a hemp industry. And so, the big question for our farmers is, where's the market? I don't want to grow it unless I know I can sell it. So part of my reasoning for doing this podcast series is to look at the market and see what people are doing and how they're using it and sort of try to project that into the future. And so it's fascinating to see what you're doing up there. Can you tell me more about how you work with the farmers? Do you contract with them directly, or can you explain what you said?
Well, we currently we don't, but down the road we probably will. And that is, it would be simpler if they could just drop their crop off at the factory door. We would separate the hemp the fiber from the hurd. Mm-hmm. Use the hurd for the blocks, which is about 2/3 of the plant.
Okay.
And then sell off the fiber to various people that wanted to use it.
Right.
We were approached by a very large American car company, and we would have had to have four full-size factories up and running just to do their pilot line for hemp fiber. So right. We couldn't do it.
Right.
So, but we know that opportunity exists, mm-hmm. and there's now Europeans over in Canada now scouring for hemp fiber because they don't have enough over in Europe.
Right. Okay. Getting back to your blocks, is there an easy ratio between acres of hemp to numbers of blocks produced? Is there a way to break that down?
Yeah, it's about 10,000 acres will produce 4 million blocks.
Okay. And then how many, average size structures can you build out of 4 million blocks?
Well, I would say just wet finger in the air, probably about 4 million square feet.
Wow. Okay. And how many projects do you have completed or in the works right now?
We have 3 completed and 1 more in the works. We have a number of projects on the books that want to use our system, but the company is just now transitioning from to a fully automated production line.
Okay.
So that's the transition that we're in right now. As soon as we finish that, we have numerous people interested in becoming plant owners and managers in both in the U.S., Europe, and China and other parts of the world. So we need to finish off the work and being fully automated. We have the design, so we're just implementing. We're starting to implement those designs right now so that we can keep up with the market. We've never been able to get close to. We get 2 projects a day off our website, and we can't do any of them right now. Our queue is full,
right? And
I would say our queue is full for the next 2 years.
That's a good problem to have, right?
Yeah, it is, and it isn't. We just can't help people that want to go ahead with this. So, we would like to help more people, but where we're at right now is we're just in that growth stage, in that transition to, and we expect to be able to easily, but we expect to be able to produce, the number of blocks that we need to satisfy only the people that are insiders in the company, actually.
Okay.
Even if we had a fully operating plant, we would never get near the market demand for this because of the savings in energy costs and especially not needing air conditioning in most places.
Now, do you have a patent on the block, or is this something that other people can replicate around the world?
No, we're patented all over the world, and the patent is very strong. So we have we're pretty pleased about that. We spend a lot of time and attention on that, as you can appreciate.
Sure.
Because this is a new. Let me put it this way: if you were putting a structural frame in a insulating material, any insulating material, you would be violating our patent.
Okay. Right. So it's not necessarily the material it's made from, but the structural integrity of the block itself.
Yeah.
Okay.
Yeah. We have looked at different materials in different places in the world. Mm-hmm. Like some places have different materials, but we haven't found anything that works as well as hemp hurd. It just has all the elements. That's just at this point, but we may in the future. We don't know.
Right. Now, is that something that you would then license that technology out to folks who want to build this way, or would you have to sort of control the entire market?
No, we would license. We would. We have a number of people that want to look at various forms of working with the company. There's some people that want joint ventures. There's some people that want licenses. So we don't have a formula 100% figured out at this point. We have some Europeans that are very that want to take it on and kind of dominate the market over there. But we haven't. We've only got the one production facility right now,
okay. And
we need to be fully automated and be able to transfer the entire technology prior to, and we will define how we're going to do that as we get further along. I don't think there's going to be any one particular rigid formula because, there's different circumstances in different parts of the world. So you have to be somewhat flexible as to what the actual circumstances that you're dealing with are. So,
do you get much resistance from, let's say, zoning boards or municipalities where your structures are being built?
We've got our certifications done here. We are stronger than poured concrete. Most people don't believe that can be possible, but we are.
Right. We
have a 2-hour fire rating. We have our hygrothermal testing done, so we know how moisture transfers in and out. All of these tests have been done over the last 4 years. And so once the engineers understand it fully, then they sign off and stamp the drawings.
Okay. And
it takes longer to get on a national registry, but our certifications are ASTM. So they're good internationally, not just good for Canada.
Okay.
They'll be good for the United States. They'll be good for anywhere in the world. When we originally started our process of certification, our instructions were to our lead engineer that we had to be able to build anywhere in the world because, for example, just because you're on the National Building Code in Canada doesn't mean that you can get a building permit in Vancouver, for example. You can't. So what does it matter if you have that designation? What you'd really need is all your testing done in a binder that all the engineers can understand.
Got it.
That way you can get a building code or you can get a permit to build. So that was our original instruction. And then as we go along, we will be on the national building codes of every country that we're building in.
Okay. What has the Canadian government or the provincial government of Alberta done to, incentivize your industry and your business?
The Canadian government has given us some grants, and so too has the Alberta grant, or Alberta has also given us incentive grants. So we're working off one in Alberta right now as well. We have another one that we're applying for the Canadian government.
Okay.
So both the Canadian government and the Alberta government have been really helpful and forward-thinking. They're very impressed by the results that we've attained. And so they're helping us now even further. So we're very happy with that.
Okay, so there are some things that governments here in the States might learn from the Canadian model to get our industry started here.
Yeah, I don't know. I don't know what you have or what the differences would be.
Right.
I know that in Germany, for example, they have all of the resources identified for a plant right now. Even they're so fast over there that I think we could all take a page out of their book. They're very and a lot of government support for anything with the nature of helping the environment. They're all over it there.
Yeah, it's a slightly different environment here in the U.S. when it comes to some of this, which is crazy to me, but it is what it is, and we're trying to change things little by little. Can you just really simply break down your process for creating a block? Do you mold them one at a time, or do you make a bigger piece that's then cut into smaller sections? How does all of that work?
You mix the formula for the hemp line, You put a structural frame in a mold.
And what's that frame made from?
The frame is made from a composite. It's a composite that's used similarly in a lot of automotive parts, but it's our own formula.
Is it petroleum based?
It's not plastic. It's food grade.
Okay.
And it's mainly not. I think there is some petroleum in it, but it's only about 4%.
Okay.
But it's mainly other elements, and I can't give you that formula, but I can tell you that it's over 70 megapascals when it's in a wall.
I'm not quite sure what that means, but I'm going to take your word for that, Michael.
Yeah, it is. Well, concrete, high-rise concrete wall is 50, so we're quite a bit more than that as far as strength is concerned.
Okay, so you mix the ingredients, you have the structural frame, and then what happens?
And then there's a process of tamping the block in the mold so that it forms a block. Then it comes around and it's demolded. And then it goes through another, the mold goes around again and gets used again. The block goes down a conveyor and gets loaded into a CO2 enclave. The CO2 enclave then hardens the block with CO2. Then it's taken out and put back on another line, and it gets scratch coated. So it's a hydraulic lime coating, so that it doesn't chip and stuff in shipping. Mm-hmm. And that's the way the block shows up on the development site.
Now, whose idea was this? What bright mind invented this block?
This was invented by Mac Radford. Mac was a developer and builder, and I financed Mac many years ago on a project. So when he was, and I continue to finance him with this invention.
Okay.
I financed him several times, and then he and I worked together on several projects. So that's how. That was about 30 years ago.
Oh.
And so we've known each other for a while.
Sure.
So he's built numerous buildings, and he had his own engineering firm as well in Toronto. And he is also, I would say, a genius IQ. There has been 1,000 inventions that he's come up with to make this whole building system work. I'll give you an example of his ability. We were on site on our first build, and he found that two of the inventions that he'd come up with for applying mortar and glue to as part of the process, you put mortar in between the blocks. Mm-hmm. And so the applicators that he designed and developed didn't work. And or they worked, but they were extremely cumbersome.
Okay.
And so what he did is he left the site, came back later with two fabricated pieces and exchanged them on the system, and they worked brilliantly, and they're still being used today. So I was so impressed by that. Like he just walked off the building site, had another idea, went and fabricated it and brought it back, and it worked. You know, I mean,
nice. Right.
To me, that's amazing.
Sure.
But I don't have that gift, but he certainly has it in spades.
So what was that initial conversation like with him when he brought to you this idea of these, prefab hemp blocks?
That's another kind of cool story. He phoned me. He was living up in the interior, it was about a 500-mile drive, and he said, remember that conversation? We had a conversation 10 years earlier where I said, the environment's not doing very well, maybe we should stop developing, and I should stop financing developments, and we should do something to help. And then he phones me 10 years later and says, that conversation we had, I actually did something about it. And I said, oh, well, what did you do? He says, well, I'll come there and show you. So he drives 500 miles. He goes in the alley behind my house, and he pops the trunk open, and he says, what do you think of that? I said, well, what is it? And then he stacks up these blocks and like Lego. And I said, oh, well, what is it? And he says, oh, it's a building system. And then he started to explain it all.
Right.
And I looked at it and I said, wow, well, maybe that'll work. And then I got on the internet and I learned about hemp and lime and how it's been around for thousands of years and as a building material and all of these other things and how they're using it in different parts of the world in different ways, and none of them looked as cool as this. So I became an investor, and then I brought my friends in and my family in, and I'm still bringing people in, and it's probably the best thing I've ever done, I would say, and I'm 70 years old, so I've done a few things.
So how do you measure success?
I measure success by the excitement that I see in my friend who took on the first building, and he brags about his home to everybody that comes near. And to me, that's success. He's a double PhD in engineering, and he's lectures all over the world. So he's a very intelligent man. He took it on with a pioneering attitude, and we had made a whole bunch of mistakes on the first building that we did. So he was patient throughout all of that. And now there isn't anybody that he doesn't get excited in front of with the results of the house that he lives in. He thinks it's the best thing that he's done. So he brags about it. He brings his friends in and brags about it to them. And he brags about his energy bill being way lower than theirs, and how he's charging his 2 Teslas that he brags about on it as well. And what can you say? I think that's success.
Right. What needs to happen for more structures to be built from hemp?
Well, right now it's the automation. We're not, with the current manufacturing process, we're not meeting, not even getting close to the demand. So we have to kind of just step back and fully automate this process so that we can get way more blocks out the door as fast as we can, because we can't. There's no way that we can keep up with the demand. So that's what we need to do, and that's what we're focused on. I'm raising financing for that portion of it, and then we can transfer it from that all over the world. We're just bringing in the high-level people that can, engineering group that can, they've built oriented strand board plants. I don't know if you have them down there, but they handle fiber, they handle molds, they have presses, they do all the same things that we're doing, only on a much larger scale, I guess.
Okay.
But anyway, so they're coming in and helping us to fully automate this process.
All right, so this might be sort of a stretch of a question, but do you have any advice for farmers interested in growing industrial hemp?
My advice is to grow. Well, there's 3 markets that exist here now that farmers are growing it for. They're growing it for CBD production. You've probably heard about that.
Sure.
They're growing it for the leaves are high in protein, so they're using the leaves for animal feed. So they so that's an option. The fiber has a very strong market all over the world, so the fiber is also an option. So there's different varieties out there for use for different reasons. So you have to, look at your opportunity, and then we can come along someday and pick up the hurd and make building materials out of it.
Okay. Michael, any final thoughts or anything else you want to share with our listeners about Just BioFiber?
I just think that the company itself has come up with a game changer, if you like. I go to all the green build shows, and a lot of it, you can call it green build or you can call it green wash. It seems like there's nothing, there hasn't really been that many changes in construction over the last 100 years. Mm-hmm. And this is something, we arrive at the building site pretty much carbon negative. And not only that, after the fact, we're not burning up a bunch of energy. We don't need a bunch of air conditioning and all these other things. And it's really we're getting back to a simpler, more robust way of building with this invention. It's like a new way of doing something old. So that really works and has always worked. So I think this is very exciting. It's a really going to make a difference in the world. And that's my view 4 years later. I usually don't last a couple of months on something if I think it's not going to work, but I'm still very excited about this.
Right, great. Well, Michael deChamplain, thank you very much for your time today. It's been fascinating to hear about your company and the products you're making.
Thank you for spending time and learning about what we're doing, and hope to see you in the future.
All right. I hope to see all of you in the future, too. Thank you for listening to our podcast today. And hey, speaking of the future, a couple of things that you should know about. Number one, Pennsylvania has lifted the acreage cap for permit holders. In the first year, you could grow 5 acres. In the second year, you could grow up to 100 acres. But it hasn't been officially announced yet, but I do have confirmation from the Department of Agriculture in Harrisburg that yes, they've lifted the cap. That means unlimited acreage. So that's a big deal, and I think we're going to see industry start to move now. The second thing, speaking of industry, a Canadian company called Canopy Growth, they just announced that they're going to be investing somewhere between $100 and $150 million into a hemp industrial park somewhere in New York State, probably in the southern tier. So that's exciting too. It's starting to get real here with hemp and agriculture. And so maybe by next week I'll have more information about those things, and hopefully we'll get to talk to some people about them. So, all right, in the meantime, I am your host, Eric Hurlock, digital editor at Lancaster Farming Newspaper, and I will see you next time. Goodbye.